practice test that I put online. Remember, what's online is like way more than you would actually see on the test. There's just a couple of each type of problem, so you can kind of pick and choose through that practice test if you want. If there's a certain type you want to practice or something, you can do that, and the solutions are posted. Okay, so all about probability. So number one, a student must choose from 7 classes to take at 8 a.m., 4 classes to take at 9 a.m., 3 classes to take at 10 a.m. How many ways can the student arrange their schedule? So when we talk about how many ways, this is not a probability. So all you're doing is multiplying things together to get this. You're not doing any of the division out of the total. We'll get to probabilities in a little bit. So how many choices essentially for each class is what you're going to be looking at. This is that multiplication principle. How many choices do we have for the first class? 7. Second class? 4. Third class? 3. And then we just multiply them together. 7 times 4 times 3. And you're going to get 84 different ways that the schedule could be created. Okay? All right. Number 2. Your travel agent is arranging your honeymoon. You have several choices to make. You will be staying in 2 different hotels, taking 3-day tours, and eating dinner at 5 restaurants. There are 5 hotels, 7 tours, and 11 restaurants to choose from. How many different combinations can you choose from? And it says order is important for the reservation. So if order is important, first of all, are we using a P or a C? That's a P. Order is important. P. Okay. So let's just talk about the hotel. I am going to pick 2 different hotels, and I have how many to choose from? 5? Okay. So my hotels are going to be 5, choose 2. Those are all the different ways we can make our hotel reservations. We're going to pick 3 day tours out of 7. So 7, choose 3. And then we're going to pick 5 restaurants out of 11. 11, choose 5. All right, so let's see what each of those are. Remember, hit the number first, so hit the 5, then go into your probability menu to select it. Choose. Two is 20 choices for the hotel. Different ways we can do that. 7, choose 3 is 210, and then 11. Oops. Choose 5. We got a lot of options there. 5, 5, 4, 4, 0. And then we're not really, well, we're going to just multiply these together at the end then. Just again, kind of our multiplication principle. And we get a lot. 2, 3, 2, 8, 4, 8, 0, 0, 0. Okay. Questions there? Okay. All right. Number 3. Using the table, find the probability that a randomly selected degree will be in business or psychology. When you see the word or, what are you doing? Adding or multiplying? You are adding. Okay, so we're finding the probability that they're business, probability that they're psychology, and then adding them together. So business, there are 361 of them. We'll get the total in a second. Psychology, there are 114 of them. And actually, they gave us the total at the end. How wonderful. 1,006. If not, we would need to do that work ourselves. Okay, so probability that the business, 361 out of 1,006. Psychology, 114 out of 1,006. I'm just going to add my numerators together first. 475. And then divide by 1,006. And then let's give answers in decimals and round to 3 decimal places would be appropriate. Yes? Oh, it is other. Oh, that stinks. I was like, oh, that's not the name of a degree. My brain's not working this morning. Okay, so let's add them up. 181, 178, 114, 1006. 1840. Okay, let's fix that. It almost looked like it could add up to that. I guess it's a little small. All right. Change my denominator. There we go. 0.258. Okay. What is the probability that the degree will not be in health? So if you see the word not, what type of probability could you calculate, or what could you do with your probabilities? You could use a complement here. So you could find the probability that they are a health major, which that's pretty quick. 181 over our total 1840. And then everybody that's not that is just 1 minus that value. Okay? And again, you can use your calculator. 181 over 1840. 0.902. Okay. Questions on number 3? Okay. Number 4. A basic Ohio license plate has 3 letters and 4 digits. Let's say there is a restriction that doesn't allow for letter A to be the first letter and doesn't allow for letter Z to be the last letter. Also, let's say that you can repeat the letters but not the digits, and all the digits have to be even numbers. How many different license plate are going to be possible with this restriction? Okay, so I'm going to kind of leave my spaces here. I have 3 letters and I have 4 digits. And we've got to figure out for each of these how many options we have. Okay, so let's say it says you can repeat letters. So let's focus on the letters first. The first letter cannot be an A, so how many choices do we have for it? 25. The last letter is the other one that has a restriction, so I would put that on there next. It doesn't allow for a Z. So again, 25, because we are allowed to repeat those digits. And then it doesn't look like there's a restriction at all on that middle digit, so we're just going to say 26. Okay. All right, we are not allowed to repeat digits, and all the digits have to be even numbers, and 0 is going to be counted as an even number. Okay, so how many even numbers do we have then out of our digits? Well, our digits are 0 through 9. Those are our choices, yeah? So there's 10 of them. How many of those are even? 5. Okay, so for the first digit, I have 5 choices, and we are not allowed to repeat the digits. So for the second digit, how many choices do I have? 4, and then 3, and then 2. And you just multiply them all together, whatever that is. And I get 1,950,000. 1,950,000. Okay. All right, number 5. A card is selected at random from a deck of 52 cards. Find the probability that the card is a club, again, or a 7. Okay, so remember we are adding when we see that. How many clubs are in my deck? 13 out of 52. How many 7s are in the deck? 4. And then we have to think about if these are mutually exclusive or not. Is there a card in the deck that is both a club and a 7? Yes, so that guy got counted twice in both groups, so we have to subtract it. We subtract the club, 7 of clubs, the one card that they have in common. So again, you can just do all the numerators first here. You're going to have 13 plus 4 is 17, minus 1 is 16 over 52, and then divide. And you get 0.308. Okay, the next one says, find the probability that the card is a face card given that it is a heart. So remember when we saw the word given before, think of that kind of like your denominator. We know it's a heart. So if we know it's a heart, how many hearts are in the deck? 13. That's the denominator. Out of those 13 hearts, how many are face cards? Well, which things are considered face cards in a deck? King, queen, jack. That's it. Anything with a face. So there are 3 of them. That's it. So 0.231 is our probability. Questions on 5. Okay, number 6. In a sample of 28 puppies, 18 of them are labs. The rest are silly little chihuahuas. I didn't write this problem. If you grab 3, just a little disclaimer there. If you grab 3 puppies at random without replacement, what is the probability that all 3 are labs, none of them are labs, and at least 1 puppy is a lab? Okay, so let's start with the probability that all 3 are labs without replacement is key here. Okay, so what's the probability that the first puppy is a lab? 18 out of 28. Okay. Then that puppy is a lab. We leave it out of the group. So what's the probability that the next puppy is a lab? 17 out of 27 now. And then the third puppy, what's his probability? 16 out of 26. Multiply them together. So on top, I get 4896. On the bottom, multiply straight across, 19656, and then we divide. 0.249. Okay. What is the probability that none of them are labs? Again, without replacement. So what's the probability that the first puppy you select will not be a lab? 10 out of 28. And then this is going to be similar, 9 out of 27, 8 out of 26. So on top, 720. On the bottom, I'm going to get that same number again that I had before. .037. All right. Part C. What is the probability that at least 1 of the puppies is a lab? At least 1 is the complement of, it's a fun little rhyme, complement of none. And we already found that, right? No labs was part B. So complement of part B gives me 0.963. Questions on number 6? Okay, number 7. 62 actors showed up for an audition for parts for a new movie about the Beatles. In how many ways can the director cast the roles of John, Paul, Ringo, and George? Okay, so how many ways again? So this is either going to be a permutation or a combination. Does order matter here in the selections that are being made? Yes. Because let's say you select the 4 guys. You then have to give them each a part, right? So you could give guy number 1 John and guy number 2 Paul, and that's a different play versus if I switch the roles, right? So when you're placing people in a certain position, order matters. So if order matters, what am I using? I'm using a P again here. And it's 62, choose 4. And you can just do that with your calculator. And we get a big number. About 13 million ways we can do that. Okay. Number 8. An employer must hire 2 people from a list of 13 applicants to be new computer techs. In how many ways can the employer choose to hire the 2 people? Do we think order matters here or no? I'm going to say no here because it doesn't seem like there's a difference in the 2 positions. Although each person is getting a job, they're both going to be computer techs. So it really doesn't matter who we hire first and who we hire second. Both of them are going to be a computer tech at the end of the day. So order doesn't matter here, which means I'm going to use a C. 13, choose 2. I get 78 ways that can happen. Okay. Number 9. Evaluate. You can just use the calculator for this. This is just a little practice with that expanded form. You can type this all in at once if you want to. Just be careful with parentheses in this red calculator. You guys know where the factorial symbol is. If you're going to type this in, you're going to need a double parentheses around where the denominator is if you want to do it all at once, which I think honestly is going to be easier because you're going to get such large numbers for that numerator. So you're going to have a double parentheses, 67 minus 5, 5, like that. That double parentheses ensures that that second 5 factorial is going to be in the denominator and it's not being multiplied in the numerator. Okay. I'll type mine in here to make sure we get the same answer. Over. You could even change that 67 minus 5 to 62 factorial if you don't want to mess with that. And you should get 9, 6, 5, 7, 6, 4, 8. Okay. Questions on that? Didn't I divide it? I did divide it. Yes. 67 factorial is going to be a bigger number, yeah? Oh yeah, 67 factorial is like something times 10 to the 94th. Yeah. If you recognize what it is, yes, you can do that. Yes, so this is our combination formula. Okay. I don't think you need to in the red calculator. This is why we're practicing with them today. I want to make sure we were good on this. You don't need to. It doesn't hurt if you do. For sure. Are they able to get it okay? Yeah? Okay. All right. Football team has 53 players. There are 28 that are on the offensive roster, 25 that are on the defensive roster. Suppose 7 are chosen at random to be drug tested. What is the probability that 2 of the offensive players, or 2 are offensive players and 5 are defensive players? Okay, so this problem is a little similar to what we did with, you guys had this on the bonus on the quiz, I'll get that back to you today, with like the full house problem or 4 of a kind, 1 of a kind. We did a problem in class that had to do with like jacks, I think, or jokers, where we're selecting a certain kind of each thing. We did one that had like corn kernels, like radioactive corn kernels, if you remember that problem. So these are all kind of similar. I think there's another one like this on here as well. The first thing we want to do is we want to look at the denominator and just figure out how many people we're choosing out of how many total. So the football team has 53 players total, and we are choosing 7. Okay, and then I have to decide, does it matter the order that I choose them in? It does not here. Okay, so we're making a team. Doesn't matter what order I choose them in, we're selecting just a group. Nobody's going to get anything in particular at this point. Okay, then there are 2 different groups that we're looking to see get selected: the offensive players and the defensive players. Okay, and each of those are going to have their own little combination that we're figuring out. So for the offensive players, how many do I have total? 28. Okay, and how many are we looking to choose? 2. Okay, and then for the defensive players, we have 25, and we're looking to choose 5. And then remember when we did this in class, I mentioned that everything on the left should add to the denominator on the left there, and then everything on the right should add to the denominator on the right. So you can kind of check those numbers before you plug it in. Okay, so again, you can do it all at once in the calculator if you want to. This one you wouldn't need any extra parentheses because your denominator is not anything weird. Just takes a minute to type in. So let's see. 28, oh, choose 2 times 25, choose 5, and then we're going to divide it by 53, choose 7. And I'm going to get a probability of about 0.130 you should get for that one. Okay. Questions on 10. Okay. Number 11. The Miss America pageant has 50 contestants. At the end of the day, they announce the 5 that are going to go on to the final round. How many different lists of 5 ladies can be made, considering that the order they are listed is not important? So if order is not important, what are we using? A C, and this is just a very quick 50, choose 5. That's it. And I get 2118760. Okay. Next. Number 12, so banking off of that, what is the probability that exactly 2 states that start with the letter A will be in the top group? Okay, so this is similar to the football problem. 50, choose 5 are all the different groups that can be made. So states that start with A, no, still 50, choose 5 here. We're going to choose 2 on the top in a minute. So there's 5 people that are in the top group. We're looking for 2 of them to be the letter A, and 3 of them are not going to be the letter A. Does that make sense? So it's kind of like my football team's on the bottom, offensive and defensive. Now my football team is made up of pageant contestants. Okay, so start with A and other ones that do not start with A. Okay, so we need to know how many states start with the letter A. Alabama, Alaska, Arizona, Arkansas. I don't know the song. Can we talk about this? I don't think there's too much on the test like this. It's not crazy. I think it'll be okay. I did not make this question. I didn't make any of these questions. Stark State made these questions. Alabama, Arkansas, Alaska, Arizona. Final answer? That sounds right. Okay, so out of those 4, how many are we choosing? 2. Okay, and if 4 states start with the letter A, how many do not? 46. And how many are we choosing from there? 3. All right. let's see. 4, choose 2. 46, choose 3. And 50, choose 5. We didn't even consider if like Puerto Rico was considered. Is that like one of the 50 state, right? When they do the pageants, do they consider Puerto Rico one? No? Or District of Columbia, is that one? That's all right. We're gonna say 50. We're gonna say 50. I feel like there's more than 50 though, right? Anybody watched that lately? It's been a very long time. Did somebody say old people watch that? Is that what you said? I didn't know people watched it either. I don't watch it, obviously.
You don't watch the
No.
You don't watch the Miss Universe?
I know you guys don't know me that well, but do I look like the type of person that's gonna watch a beauty pageant on TV? I don't know. This is not for me. Not for me. No, I do though. I will tell you, I love Real Housewives. Love it. I'm not a big fan of any that are on right now. Like New York is pretty good. So is Orange County was good, but they lost a lot of good people. I feel like Vicky's not there. Would I be? No. No. It could be. Maybe one day they're gonna run out of places to have the Real Housewives at. Okay, what is the probability that Miss Ohio will be in the top group? What is the probability that Miss Ohio will be in the top group? So again, how many groups can we make total? 50. Choose 5. And let's see. Will be in the top group. So think about it this way. We will choose Miss Ohio, and we don't choose Miss Ohio. Is what's happening right now. Okay, it's kind of like the letter A, but there's only one O. Okay, so how many Miss Ohios are there to choose from? 1, and I choose 1. And how many non-Miss Ohios are there? 49. And how many of those are we choosing? 4. So this is going to give me all the different groups that contain that one Miss Ohio. So 1 choose 1 is just 1. So it's really 49 choose 4 and 50 choose 5 is what you're dividing here. Or you can type it all in. It's a pretty good probability. She's got a 10% chance making top 5. Okay. Good there? All right. Last problem. How many distinguishable ways can books be placed on a shelf given that 3 are pre-calc books, we're assuming they're identical, 5 are Algebra 2 books, and 4 are AP Calc books? All right, so how many books are there total? There are 12 books total. So the different ways that I can arrange those is 12 factorial, 12 choices for the first book, 11 choices for the second book, so on and so forth. And then when we have identical items, we divide by how many of each type of item you have. So I have 3 pre-calc books. I have 5 Algebra 2 books, and I have 4 AP Calc books. And those denominators, 3, 5, and 4, should always add up to what you see in the numerator, 12. Sometimes we divide by a bunch of 1 factorials if some things are distinct. We don't have identical items. Then you type it in. So let's see, 12 factorial. Might be able to do this one in pieces. My numbers aren't super huge. Denominator, I've got 3 factorial times 5 factorial times 4. And then we divide them. 2770. Okay. How many distinguishable words can you make by scrambling the letters in MacDonald? Oh, I did write this one. I must have changed the word, obviously. Okay. How many letters are in my last name? 9. Okay. And how many identical letters are there? Let's see. I've got a couple D's, couple A's, and that's it. So what am I going to divide by? 2 and 2. And then you can put a bunch of 1s there if you want to add up to the 9, but it's not going to change your answer. So 9 factorial. Just type this one in all at once. Divided by 2 times 2. You're going to get 90,720. Final answer. Again, if you're typing these all in at once, when you've got a lot of stuff going in that denominator, if you're doing it in one line, you might need an extra parentheses around that denominator if you're not getting that same number, okay? Or you can type it in separately and then divide last, whatever you want to do. Everything else on here is chapter 4 stuff, I think?
Yes.
Yeah? Okay. So what we just reviewed is the type of question that you're going to see on Monday's portion of the test. Tomorrow in class, we'll go through what's left in this packet. So if you want to try it on your own and then check your answers tomorrow, or if you just want to wait till we go through it together, that's fine too. Reminder that your project is due tomorrow. So second project is due tomorrow. If you have any questions on it, you got about 15 minutes now. Please ask. I will give you a hint if you need one. Make sure everything looks okay. If you want me to check something, if it's done early and you want to turn it in, that's fine. But don't forget about that project because it's a big portion of your grade. Okay, and then tomorrow we'll finish test review. Monday, Tuesday next week. Monday, you guys also have your circuit training that's due if you're interested in doing that, which is over all this probability stuff.